Hello, everyone. I'm Kim. I'm the co-founder of the Rich Earth Institute and currently the CEO of our spin-off company, Brightwater Tools. Really pleased to moderate this panel about lighthouse projects and nutrient futures. I think one of the things that Fabian referred to was putting things into motion. And there are some people here who are going to present about projects that are starting to happen. And I know this is a small sample of projects around the world, but I think this is where we're going to start. So Lotte, Kristoferitsch, is going to present first from Austria. Lotte is a manager at the multidisciplinary studio EOOS Next. EOOS Next is an industrial design studio and a social enterprise that strives for positive change by designing transformative technologies currently in the fields of mobility, health, water, self-sufficient toilets, yay, and electricity, with the aim to drive forward the development of social and sustainable design projects. So Lotte, there you are. Hello, it's been a while to see you. And
thanks for the introduction.
We'll, have you share your screen and okay.
Yes, so I'll share some slides. I hope I'm able to tell you something new, as all of you are experts. And thanks Fabian for making the stage. I'm going to talk a bit about how it's starting. So I'm talking about the toilet that you all might need to collect urine. As most of you might know, we are the studio that started implementing a passive urine separation called urine trap, a technology that we have been implementing in various typologies in the past year. This is just to start the conversation about how these systems look. This is a flush water mounted toilet we did for a Swiss company called Laufen. We did a squat pan for emerging countries in the global south. This is one of the field tests where we have been evaluating the separation efficiency. But I think very excitingly, we have been developing a vacuum urine diverting toilet in the past year that is currently being tested in India, in the Goa region, where we are demonstrating the improvement of existing biodigester systems by the integration of our urine diverting technology. So what we're doing here is, as in India, most of the users are washers. We are using the urine trap as an overflow for the high amounts of anal cleansing water. So as we stick to literature and to user groups of five people, what we have been measuring in the past years that there's an additional 120 liters of anal cleansing water that needs in a way to be treated separately to avoid poor performance of biodigester systems. So we use the urine trap as an overflow and divert urine and anal cleansing water through a two-step wetland treatment, while feces and a very low amount of flush water, as it's a vacuum technology, is being diverted into the biodigester, which after this implementation of our urine diverting vacuum toilets is performing way better than it did before. So we started with some benchmark tests. So we are using an existing biogas system that is provided by the Indian government. It exists in high numbers all over India, but due to the high anal cleansing water input, the biogas performance is insufficient. So we selected a few sites where we are benchmark testing, all on a household scale. So you always see these blue cabins. This is where toilets were integrated prior to replacing them with vacuum systems. And this indicates the status before integrating the vacuum toilets. So as you see, we were benchmarking ISO 3500, which is the ISO standard that the Gates Foundation has been implementing, as well as CPCB, which is the Indian standard, which is a bit more strict. So this is another benchmark system where it's a biogas tank with the bio-wetland attached to it. Again, you see the sampling points. This is an image from the actual installation. This is again the benchmark result. So when we first started measuring after several weeks of usage of this benchmark system, and again here you see that important criteria is not matched at all. And this is the first image of one of our systems being integrated. We are in a prototype status, so this means that the front end itself is already produced out of ceramics. But the vacuum system and the control system are still at prototype level and not industrialized. So, but the nice outcome of this first test is that actually after not even a month, we could demonstrate that important criteria in terms of performance and treatment were already met, which was a huge step for the project already, and this has been met in both settings. So that's the second setting where again 2 household units, and one of the toilets is a male user toilet and the other one is a female user toilet, have been connected to this biodigester and then to this cascading wetland. This is a picture from when the project started, so you don't see any plants yet growing, but after, and we've been testing for 2 months now, so it looks a bit lusher and alive already. Which might be interesting to some of you. This is how the toilet looks. So it resembles a lot to the Laufen Safe toilet. It's we just reduced a bit the inside geometry to make it perform as a vacuum system. Yeah, and these are the outcomes of the second test site, where again you see after very short performance and sorry, very short usage period, we already have very promising results. Looking at it now, the few areas that are still remaining yellow already turned green. We have not. I received the final data from the first 8 weeks of operation today, so we haven't refreshed them. But we're very confident about this outcome, and really do hope that this, on one hand, this vacuum system as a tailor-made improvement for the Indian market is going to become a big success, but also that knowing that there are many projects all over the world waiting for urine diverting vacuum system. Yeah, I think I'm very confident that we can contribute to also enabling systems that are help, yeah, maybe help projects that have been waiting for vacuum systems for a very long time. Yeah, in case you have any more questions that I am not able to answer in the upcoming minutes, please get in touch directly. I'm more than happy to answer and follow up on anything that you might know. Thank you for your attendance, and I hope you enjoy the upcoming presentations.
Thank you so much, Lotte. This is really good news, and I'm glad I'm sure everyone's really pleased to hear about the new vacuum flush UD system coming out of EOOS. We'll go ahead and complete all of the panel, and then we'll have follow-up questions at the very end. So if you can be patient for that. Next, I'm going to introduce Pete and Pat. Pete Munoz is in Oregon this morning, and Pat Lando is here with us in Vermont. So it's very exciting to have both of them here. I'm going to let you know who they are if you don't know them. Pete is a licensed engineer and a certified wastewater treatment plant operator. He co-founded SEEDS in 1990, a nonprofit organization working at the intersection of the fields of design, education, and ecology. He is a partner in the Alliance for Regeneration and Eco Districts Incubator faculty. He is a partner in the Alliance for Regeneration and Eco Districts Incubator faculty member, and regularly teaches courses at Yes Tomorrow Design Build in Vermont and at the Omega Institute in New York. In addition to co-founding Nutrient Recovery Systems in 2021, Pete manages the Biohabitat's Cascadia Bioregion office in Portland, Oregon, and works around the globe helping to connect communities with appropriate, inspirational living water infrastructure. Pat has been a leader in nature-based solutions for over 30 years and holds many positions in the field of water reuse, water and resource recovery. He is the executive director of RECODE, a nonprofit organization that creates sustainable and equitable building code and policy solutions for water, sanitation, and nutrient recovery systems. Pat is the co-chair of the National Gold Ribbon Commission for Urine Reuse. And in 2021, he joined the People's Water Project Steering Committee to help the coalition draft national water and sanitation related policies. We're very pleased to welcome both of you here and there. And Pat, you can come forward and start off your.
Thanks everyone. I'm so happy that this is kicking off really well. First day of the summit. We're going to quickly run through sort of what's new in our world. So we've been, Pete and I have been down this path of nutrient recovery and talking and trying to get developers and architects to incorporate nutrient recovery for a long, long time, probably 15 years or so, maybe longer, I don't know. Well, we finally got a building to put in a system. So this building that we're looking at right now, it's in Portland, Oregon. It's Portland's first living building. It's called the PAE Living Building. So it produces all its own energy. It collects, treats rainwater for potable drinking water in the building. It recycles all the other water into all non-potable uses. And the entire building, although it is connected to the sewer, uses composting toilets and a urine diversion system. So that's where we're at right now. That's where Pete is right now. This is just a quick diagram of the different systems. So I'm going to first click on, here's the composting toilets. So there's 20 of those in the building. And so it's managing all of the solid waste and some of the liquid waste. We have, these are all attached to the toilets. I wish we had, and we tried to get vacuum toilets into this building, but it doesn't have it. So it all operates on a vacuum system for the toilets and for the urinals as well. So we're going to concentrate on the urinals right there. And this is kind of the system that Pete's going to be walking through. We are essentially holding the urine on a feed tank, and then we're processing it, and we're creating a shelf-stable fertilizer product that I brought that's up on the front table that's a distillate. So if Pete's ready, we're going to give him...
Hi, Pete, you're there.
Hi, everyone. Can you guys hear me all right?
Yes, we can see
Great.
you and hear
All
you.
right.
Go right ahead.
Awesome. So I'm going to try to do this from my phone, but this is the entire treatment system. Pretty small footprint. We run this system about under full design 24 hours a month. So this scale system can be scaled up about 30 times for the flow that we're feeding. As Pat mentioned, we have a couple different systems in the building. And here, there we go. A couple different systems in the building. We have composting toilets. We have urine diversion. We have urinals that are diverting the urine. And so we have a tank right here in the ground under the slab. It's a 3,000-gallon tank. We can collect leachate, extra leachate from the composters, and urine. And so we could run both feedstocks through the system. This is our system, our column, main treatment system. Hopefully you can see that all right. This was developed by AEM. If I can get in here. This is our control panel. You can see we have a urine tank and a leachate tank, so we know how much product we have in each tank. This is our column. Pretty simple. There's 3 major components in here. Can you guys see this all right? There we go.
Yes, we can see it.
There's a large distillation column filled with packed media. I'm going to zoom in so maybe you can see some of the media in there. It's a little steamy. But there's a packed column, a steam generator, and 2 condensers. Fairly simple. We kind of put it in this cabinet just to, we want to have it as hot as possible. So we're trying to save energy. So, and it also helps mitigate odor as we're running the system. We have a couple small peristaltic pumps down here. So the whole system is just running on peristaltic pumps that are pulling out of our feed tank. We feed urine to the top of the column. We put steam in the bottom of the column, and we strip out and volatilize all of the ammonia. Our condensers condense it and store it in this right here. I'm going to open this up. This is, we just have this containment just in case there's a spill. We have secondary containment, and we also are venting this to deal with any odor concerns. So all of our distillate is captured in here, and then from here we bottle, and I think Pat has some samples of what our bottle looks like. A couple other things we're doing is we do use water to cool in the condensers. So we have a small tank that we're capturing that water, and we can recycle that as we are cleaning up and starting the system and doing things like that. We do have two different feeds. We're feeding to make sure we have pH in our system. So we have a pH buffer, and then we also, and so that helps our our distillate production. We're also producing a second product after we volatilize all the nitrogen. We still have phosphorus-rich water, and so we have a second pump that pumps up to this crystallizer. We're adding a little magnesium here, and we precipitate out our struvite. We can pull from the bottom of this clarifier, and we overflow into a small filter just to make sure we're not losing any material. We take that kind of wet sandy sludge, we put it in a handy tray like this, and put it in our oven, bake it at about 35°C for a couple days, and produce, Pat, do you have samples of that? Maybe not. If Pat doesn't, this is kind of what that looks like. It's just a powder granular phosphorus product. And, you know, this is what's going in, our raw urine, a crystal clear distillate product going out, and then also our struvite. Kind of went through that super quick. Sorry for the quickness and delay in time. But if there's any quick questions, maybe I could say one more thing. We do have a way, we're monitoring both the head temperature and distillate temperature. This is part of our permitting requirements from the state, that we're meeting a pathogen kill going through our system. And then we record that. We have, you know, data that we submit. As we're running stuff, we record how we're running the system, what the feedstock is, what our product is, and we submit that annually to the regulators.
Thank you.
Any questions?
That's just so great, Pete. I'm personally thrilled to get to have this private tour through this facility that we've been hearing about for so long, and now we have all the answers. So thank you, many answers to many questions. Thank you so much, and thank you, Pat. Yeah, I think we can go ahead and take a few questions. How much more time do we have, Julia, for this particular part of the summit? We have 10 minutes. Okay, so I think if we could keep you on the screen.
Sure.
And others.
If there's not too much background noise, I'll mute, and then if there's questions, I'll unmute.
Sounds good. Sounds good.
And then I'll just, as an open invite, anyone in Portland, Oregon, feel free to reach out to Pat and I. Will give yourself a real tour, a real life tour.
That'd be terrific. That's great. Okay.
Thanks.
Thomas Starck is a third-year PhD student in the OCAPI program in France, and his work is focusing on nutrient flows at the regional or national scale. So, Thomas, if you're ready, we can have you share the screen and go ahead.
So thank you for having me. So I'm a PhD student from Fabien, who just presented in the keynote. And I'm not going to present about some projects, but more about the current situation of the French sanitation system and what insights can be drawn from it for future implementation of urine separation and nutrient recovery. So it's an assessment of the current non-circularity and the lessons for nutrient futures. Starting with the key points, what you can remember is that currently in France, you have about half of the phosphorus and 10% of nitrogen extracted by French people that are recycled back in agricultural land. And actually, when we did a benchmark, it's kind of the highest recycling rates in the Western Europe. And so this is about the recycling, but if we look at what is more commonly monitored, which is the wastewater treatment plants removal efficiencies, it's more about 80% for phosphorus and 70% for nitrogen. That means what is removed from the wastewaters in order not to pollute water bodies. And what you can see is that what is monitored currently, so the removal efficiency, is quite different from the circularity of the whole system. Very quickly, my work is built on a large data set of the 20,000 wastewater treatment plants in France. And I'm presenting you the summary of it with the flows at the national scale, but behind this, you have the data for all these plants. And so what you have here, you have a quick glimpse of the individual removal efficiencies from all the plants in France. So the current sanitation system, starting with the phosphorus budget. So the journey starts with the excretions in the toilets. This goes to the sanitation system, but you have also some other flows, namely the large industries discharge in the sewers, and also what I call residual. So that's what you see at the entrance of the wastewater treatment plant, but that cannot be explained neither by excretions nor by large industries. So that includes detergents, the waste, the food waste that goes in the sinks, and so on. And in France, so the situation will be particular for each country, but in France, you have 85% of the people that are connected to the sewage network and 15% that are not connected, and so that have their own individual autonomous system in their household. So it's basically septic tanks. These septic tanks, when you do a life cycle analysis, actually, you can see that most of the phosphorus, you can see my mouse, my pointer, I don't know. But most of it is lost to the environment, so in the underground, the water bodies. And a small part of it goes to the sludge and is brought back to the wastewater treatment plants. Before the wastewater treatment plant, you also have some non-negligible losses in the sewers due to stormwaters or leaks in the sewage network. And so you don't have a lot of data about this, but our best guess is that it's around 10% based on the data from French water agencies, but with big uncertainties. And so it could be around 5% or maybe 20%. And so here is the focus of what is monitored currently. So the national removal efficiency at the French scale is 80% for the phosphorus. And so that means that for phosphorus, out of the 100 that are coming into the wastewater treatment plant, 80% is removed. So you have 20 that are going to the rivers. And in the case of phosphorus, all that is removed is going to the sludge. And even there, it's not the end of the journey because only part of the sludge are recycled to agricultural land. So only 3/4 in France. And when you take a look back at the whole system, that's how you end up with only half of the phosphorus excreted that is recycled. You have 15% that could be recycled, but is lost because the sludge are incinerated or landfilled, and about 1/3 that is lost to the environment and that pollutes the environment. So the discrepancy between the removal efficiency and the global recycling rates are due to losses outside the wastewater treatment plants and also sludge that are not recycled. For nitrogen, the beginning of the journey is quite the same, but you have a big difference. So first small bit difference is that the removal efficiency is a bit lower for nitrogen, so 70% and not 80%. But the big difference for nitrogen is that out of these 70% that are removed, most of it does not go to the sludge, contrary to phosphorus. And actually, the main part goes to the air. So because of the nitrification, denitrification process in the wastewater treatment plants. And that explains why you only have 10% of recycling for nitrogen. Like phosphorus, you have losses outside the wastewater treatment plants, but most of the losses are due to dinitrogen that is lost to the air because of the process in the wastewater treatment plants. And so you have the big discrepancy with the apparently good removal efficiency that is 70%. And so now about the future, what lessons can be drawn based on these assessments if we want to increase the recycling of these nutrients? The lessons that can be drawn are the problems of the current system. With the current system and the current processes, it is not possible to reach high recycling rates for nitrogen because of the inherently dissipative nitrification, denitrification process. So that's the big flow that you are seeing here, just after the wastewater treatment plants. So one might think that maybe we can develop some processes, industrial processes, in the wastewater treatment plant to recover nitrogen. So these processes currently do not exist at the industrial scale, but even if we develop such processes, as exemplified by the phosphorus case, you would still have some large losses outside the wastewater treatment plants. So in the case of phosphorus, these are these two flows here that represent still 20% of the current flows. The total flows are just lost outside the wastewater treatment plants. And so even with very high recovery rates, like phosphorus, 80%, you still end up with about half of the total phosphorus that is recycled. So that's an argument for recovering nutrients before the sewers. And so if you want to do urine recovery, in the case of France, you have a quick win that is people not connected to sewers. So it's 15% in France, but in your own country, that could be much higher. So these are people where they already have on-site sanitation. And so we can think of adapting the current septic tanks. But you would still have most of the flows coming from big cities and dense areas. So this will be the next presentation, for instance, in the Paris neighborhood in Saint-Vincent-de-Paul for urine recovery in urban dense areas. And I focused on the French situation. And actually, so in France, here you have all European countries on the horizontal axis, and on the vertical axis is the share of current nitrogen fertilizers that could be replaced if we recycled all of human excretions. So for France, that represents 50% of our current fertilizers consumption. But you can see that for other European countries, and in yellow, you have big European countries like Poland, Spain, Germany, or Italy. You can reach higher rates, like 20% or 40%. And that is in the current food, agricultural food system. So if we think of future food systems that are less nutrient intensive, you would decrease the needs of the food system. And so the excretions could cover higher rates of the consumption. Thank you for your attention. And so all the figures and more details are available in two preprints that you can find here. Thank you.
Thank you so much. Thank you, Thomas. Really appreciate that update from you. And as people just remind people that these are all being recorded. So, you know, if you are not able to attend any specific session during the summit, you will be able to find these online in a few weeks when they're posted. Next, we're going to have Julie and Mathilde from Paris, Julie Ginesty and Mathilde Sageot. Julie is the Sustainable City Officer for the Paris and Metropolitan Aménagement. Mathilde is the Study Manager for the Water and Sanitation Technical Service of the City of Paris. So thank you to both of you for joining us from far away today. And it looks like your screen is already shared. You can jump right in.
Well, good morning, everybody. I am Mathilde Sageot, and I work for the City of Paris in a water and sanitation technical service. I am in charge for the City of Paris of the whole source separation system in Saint-Vincent-de-Paul neighborhood, from the public pipe network to transport urine to the using of the natural fertilizer produced on site.
Hi everybody, my name is Julie Ginesty. I work for Paris and Métropole Aménagement as a sustainable city officer. We are an urban developer that works with and for the City of Paris and the Great Paris metropolitan area. And we are the operator, coordinator, and urban developer on the future neighborhood Saint-Vincent-de-Paul.
Sorry for not being with you to answer your question at the end of the presentation, but I hope someone will do it with this presentation. Julie and I will talk about the context here in Paris and about different kinds of aspects related to the source separation wastewater system in Saint-Vincent-de-Paul neighborhood.
Before entering into the specifics of the urine valorization project, we want to give you some insights about the context and the program of the Saint-Vincent-de-Paul neighborhood. So as you can see on the left with this bird view of the site, the Saint-Vincent-de-Paul neighborhood, which is located in the very center of Paris, in the 14th arrondissement, is on a 7.4 acres perimeter and is actually a former hospital. You have buildings ranging from the 17th century up until the 20th century. And I really want to stress on the fact that from the very beginnings, the elected members of the City of Paris wanted this neighborhood to be a pilot in environmental, social, and urban transition. So that's why we developed a lot of innovations on the site, including the urine valorization project. It goes from energy production to mutualized management of water, or including limitation of the place of cars on site. But I will not go into the details of that and talk to you a little bit about the program. As you can see on the right pictures with this view of what's going to look like the site when all of the construction works are over, there is going to be more than 600 dwellings. Half of them will be social housing. All of the ground floors are going to host either activities or shops. There will be a mutualized big facility that is going to be operated by the City of Paris, which is called Le Clos Pinard. It's going to host schools mainly. You can see on the left side a cultural equipment facility that we call Façade d'Enfer, and you can also see on top the chaufferie building, which is going to host in the basement the plant of the urine valorization system.
So Paris is a very dense city, around 52,000 people per square mile, and Paris has one river, the Seine River, with a lower and lower flow, which makes nitrogen water pollutions downstream Paris bigger and bigger. The surroundings of Paris are rural areas with a good dynamic in agricultural fields, and so it can be a good opportunity to value urine. Last point of context is the somewhat tense situation in Europe, which affects the price of energy and the security of supply. So the source separation wastewater system and the use of urine in fields is one of the solutions to face these issues in Paris. Therefore, in 2018, the idea of a source separation system in the will-be rehabilitated Saint-Vincent-de-Paul neighborhood emerged, and the City of Paris and PMA studied different technical and economic scenarios during 3 years, and finally, the City Council High members agreed in 2020 to experiment an ambitious source separation system in Saint-Vincent-de-Paul neighborhood. Indeed, the project of source separation system consists in 4 parts: the collection of urine in each building, the transport of urine underground to an on-site urine recycling plant, the treatment and concentration of urine, and the using of the urine fertilizer in Parisian green public spaces. Every part needs specific installations or equipment that will be detailed a bit later on in the presentation. There are different project managers for private buildings. Public or private developers are in charge of setting up the urine collect system, and they invest for that. And then they will sell the inside of the building itself, of the inside of the buildings, to social landlords, condo syndicates, or private owners. For the transport of urine, the City of Paris has called on PMA for the project management and execution of the works. And after the end of the works, the city will repay PMA and they will operate the public urine pipe network. The City of Paris is responsible for the end of the urine process, the treatment and valorization of the urine-based fertilizer. The city will call on experts with public markets for the equipment and for the operation of the urine network and the plant.
To implement the master plan that Mathilde described to you right before, and knowing that this system was very new and innovative, we tried to detail as much as possible the technical specifications that were imposed to all developers, and also knowing that we wanted to avoid any problems in maintenance further on. So it goes from the urine diversion and how to collect urine to the internal separate pipes to make sure that they will be correctly connected to the public transportation system. Just a note to tell you that the first building works will start at the beginning of 2024.
After collecting urine in each building, we had to think about the way to transport it to the recycling plant. We wanted to have as much as possible a gravity pipe network with no aerial section. We also wanted a urine pipe network to be close to other pipe networks to make works easier. And last thing, we decided to have a unique urine recycling plant on site. So there are 3 gravity pipes that collect urine of the whole neighborhood. They are 550 yards long, and they are in yellow on the blueprint. There is also a pressure pipeline in green on the blueprint that connects the pumping station to the plant. As it is quite new to have such a network to collect urine, we don't know exactly how it's going to respond, and we don't want it to be clogged. So we have a few solutions for that: manholes to see what's going on inside the pipe, flushing at the beginning of the pipe, hydro-clean, and the final one would be to deviate urine to wastewater network. For the treatment of urine, we wanted a solution with no motorized transport, so we decided to treat urine on site. However, the neighborhood is very dense and the plant should not cause sensory nuisance or any hazard. Finally, for economic reasons, it was better for us to get a commercialized fertilizer than a biostimulant. For the moment, we find just one company with the capacity to treat on-site 70 cube feet a day of urine and to transform it into a commercialized fertilizer. It's the company Vuna, and the detail of the plant can be seen on the slide. We decided that the technical room would be hosted in the Chauffeury dwellings, and we agreed on 750 square feet for the space needed. The Green Spaces and Environment Department of Paris will be at the beginning the exclusive user of the urine-based fertilizer. They must come periodically to collect the fertilizer, and I worked with them to set up the visiting frequency, the fertilizer packaging, and different kind of issues linked to that type of fertilizer.
Besides technical issues, we knew from the very beginning that we also had to address behaviors and to include users to ensure the success of the project. because you need to change your behavior to use this kind of technical installations. The first one is how to use the toilet. Everyone has to sit to urinate. And the second one is how to clean the toilet, which means you can't use any bleach or biocides. So these items really challenge the conception of what's clean, or they really address intimate behavior. So we knew that we really had to address future dwellers. The thing is, in this kind of urban project in France, future users, dwellers, tenants, they come actually pretty late in the urban development. But here we got lucky because of the particularity of this project. From 2012, when the hospital actually closed, there was an occupation transitory experience which was called les grands voisins. Sorry for my French. And this experimentation really fostered the participation of the public. And one of the conclusions that the city of Paris drew was actually to identify very early on some of the future tenants and owners. So we worked with them on different conception questions, but we also can work with them on this specific project. So now that's really where we are at. We're organizing workshops with panels of inhabitants, future inhabitants. We welcome them on the lingerie building, which is going to be rehabilitated and where we put separative flush toilets. And the goal for us is really to explain to them why we do it, how we do this project, and what's really expected of them, so we can engage in conversation and identify with them new obstacles if there are some, and if we can overcome them. But also, really what we want to do is to make them ambassadors of the project, and if they can, later on, convince future neighbors. So as I've said, this is an ongoing process. I've included at the end of the slide a video that's been made by PMA at the attention of future users and dwellers. It's only in French, but if you speak just a little bit of French, don't hesitate to click on the link.
The source separation project on Saint-Vincent-de-Paul neighborhood is quite innovative and ambitious because of the size of the collect area, the presence of a long underground urine pipe network, and the treatment of urine on site. Many technical, regulatory, and sociological subjects have been discussed with the City of Paris and PMA, so that the collecting, the transport, and the treatment of urine and the using of the urine fertilizer should be efficient and economically viable. The monitoring of the project from the very beginning and for a while after the commissioning of the plant should enable the City of Paris to replicate the project here or in another country. Thank you for listening to us.
Thank you, bye.
Thank you so very much. So do we have some questions? We have, several different people who've presented. And first for Pat and for Pete, I don't know which one of you wants to, how much does this whole system cost for you to run and how was it funded? These are really important questions. So Pete, do you want to answer that? How much does it cost to run? What were the capital costs and how was it funded?
Yeah, can you guys still hear me?
Yeah.
Okay. Cost of the system. I'm going to ballpark a few things. The main column and everything from ADM, they supply all of the tanks. The only thing that's not in this number, I think, is the 3,000 gallon tank below ground. And I think that's pretty much it. It's about 70, I think it was on 75, 85 grand for like all of this stuff as the kind of first commercial unit that went in. Not counting the 3,000 gallon tank below ground or piping from the urinals. This is a 5-story office building, so that's not an insignificant number. Since there was really no one kind of qualified to operate this system, because this is really one of the first of its kind, what we told the owner of the building, who is also the major tenant of the building, is that we would operate the system for them for 18 to 24 months and provide total open books on how much it took for us to operate and how much revenue we were generating by developing the products. So that process is still ongoing. We did set up a contract where they pay us like $1,000 a month kind of to maintain the system and operate it. So that's what their cost is right now. But hopefully next year we'll be able to present the business case for what this looks like. The biggest issue right now is this was designed pre-COVID, and they're still not 200. Originally designed for 250 people in an office building, and obviously in COVID that population is not daily. So we're kind of operating more at the 20 to 30% occupancy.
Great.
Hey, Pete, I have a question for you. I was wondering, what do you do with your products? So you have the agricultural products you're producing. Do you have a market for those? And then also for your solids from your composting toilets, what do you do with those?
Yeah, so the solids are still, there's 20 composters. The building is just about a year and a half into running. So we probably will harvest maybe a little bit this summer. It's pretty low occupancy, so we could probably even wait. There is a farm that has been designated that the composting solid will go to. Our liquid products, so as Pat mentioned, we have both a plant food, which is a 1% nitrogen, and a 5% nitrogen fertilizers or other products. So both of these products are available online as well as in 2 local stores in Portland. We kind of came online with our second product halfway through the summer or towards the end of the summer. And at that point, stores weren't buying fertilizer. So we've been collecting our network. And for this coming season, we'll probably be in about a dozen stores in the Portland area. We have commitments for orders for spring, growing push. But we're in 2 currently.
Oh, and how much? Someone has just reached out. How much per bottle?
Yeah, good question. So our 1% is $17, $18. Our 5% is $40, and it's a 32-ounce concentrate.
Okay, you want to say something else, Pat?
But Pat might give you a discount today if you want to purchase some.
Oh, sure. Put me on the spot. I was going to say we also have a Black Futures Farm, which is actually a collective of 12 different CSAs in the Portland area. And they were kind of the first people to get the distillate right when we produced it. And so they're kind of doing test run on their farm out there as well. So there's that.
Hi, thanks for the presentation. Good tour. My question is pharmaceuticals and PFAS. Is it a concern? How do you, if it is, how do you measure it? And then,
it's a good question. We're required by the state to do a whole bunch of monitoring for metals and other constituents. We're not monitoring pharmaceuticals or PFAS constituents, but because we're distilling the urine, the product or what we call the bottoms, what's left is where those pharmaceuticals or trace constituents would remain, because those aren't volatilized and condensed. If that
Can I
answers
follow
your
up with
question.
a question? I
Yeah.
follow up with the question that are you doing any collaboration with the research organization to test some of those factors?
No, but we would love to. So
Okay.
anyone that's interested,
thought I'd
please
brought
reach
it
out
up.
to Pat.
Yes. And is there another question for Pat?
Yeah, there was a lot of questions. So the composters on site are Phoenix. That system works on, it distributes, because it's a vacuum system, they operate on a manifold, so they sort of get equally doused. So that's been
I can say a bit about that. Just
the other
real.
I just wanted to quickly
go ahead.
mention that one. And then the other one is sort of this cost analysis of what we're doing. We're going to be tracking all the energy use and the cost of actually operating this and sort of reporting back in probably about a year. I think that's a big question that both we have, the building owner has, and everybody in this summit has. So yeah, those are good questions.
And I do have one more question from someone. Joe, do you want to come up and ask your question? Joe's from the University of Michigan.
Hey everyone, I had a question for Tomas. Curious about where you received your data set of wastewater treatment plant data. We're trying to replicate something similar in the US, and there's not really a national level or even a state level, compilation of wastewater treatment data. So curious in France how that works.
Okay, so in France, actually, you have 6 water agencies that are supposed to send the data to a centralized to the centralized government, but the data is not really good. So I had to go to the 6 different water agencies and then homogenize and clean the data. So it was kind of a lot of work also.
Yeah, seems like it. Thank you.
Great. Thanks so much. And thank you to everyone who presented in that panel. It's so exciting to see all of these projects from around the world.